Welcome to Educator.com. Today we're going to be talking about dividing polynomials, starting out with a review of techniques learned in Algebra 1, and then going on to learn a new technique called synthetic division. First, discussing dividing a polynomial by a monomial. The technique is to divide each term of the polynomial by the monomial. And if you think about just dividing with regular numbers, if you have something like this, you could handle it by saying, okay, 15 divided by 3 plus 6 divided by 3 plus 24 divided by 3, and splitting that up. This would give you 5. 6 divided by 3 is 2, and then 24 divided by 3 is 8. Adding this up gives you 15. You may also have done this and added 15, 6, and 24, and those add up to 45 divided by 3 to get 15. So these two are equivalent, and that is what allows you to handle dividing a polynomial by a monomial by dividing each term by the monomial. For example, 10x to the fourth plus 8x to the third minus 12x, all divided by 2x. So looking at this up here as my example of how to handle it, I'm going to say, okay, this is equivalent to 10x to the fourth divided by 2x plus 8x cubed divided by 2x minus 12x divided by 2x. And this is a step you might do in your head or you might write out. 10 divided by 2 is 5. X to the fourth divided by x would be the same as saying x to the fourth minus 1, or x to the third. 8 divided by 2 gives me 4. X to the third divided by x is x squared. Here I have negative 12 divided by 2 is 6, and the x's cancel. So my result is 5x cubed, 4x squared, minus 6. And I handled that by dividing each term in the polynomial by the monomial separately. Okay, now when you're working with dividing a polynomial by another polynomial, one technique is long division. And we've talked about this in Algebra 1, and you can also review those lectures, and I'll review it here as well. Just as with regular division with numbers, long division, you might end up with the remainder. So first, just reviewing long division, which I'm sure you know well, but just to think about the steps you're taking. You probably do this so much that you don't even think about the steps, but you want to realize what you're doing each step of the way so that you can apply it when you're dividing polynomials. If you were asked to divide something like 513 by 2 by long division, think about what you'd be doing. First, you divide. 2 goes into, you divide with the first term, using the first term in the divisor. 5 divided by 2. Okay, so that is going to give me 2. Next, I'm going to multiply. I'm going to multiply 2 by the divisor, 2, to get 4. And then I'm going to subtract that product. 2 times 2 is 4, so I'm going to subtract that. That's going to give me 1. Next, I'll bring down the next number. In the case of polynomials, I'll bring down the next term. Okay, 2 goes into 11 5 times. This gives me 5 times 2 is 10. 11 minus 10 is 1. Now I'm bringing down this 3. Okay, 2 goes into 13 6 times. And this is going to give me 12, because now I'm multiplying and then subtracting. And I have a remainder of 1. Remember that you can always check your answer by realizing that the dividend equals the divisor times the quotient plus the remainder. Looking at this with these numbers, my dividend here is 513. So it equals the divisor, which is 2, times 256, plus the remainder of 1, which equals 513. So that checks out. Now, polynomials Same concept. Looking at this example, which is going to be 5x squared plus 4x minus 7, all divided by x plus 3. Using long division. Same steps that I took over here. Okay, so I'm going to start out with x and divide that into 5x squared. So I have 5x squared divided by x, and you can see that this is going to give me 5x, because one of the x's will cancel. Okay, so that gives me 5x. Now, my next step is to multiply. 5x times x gives me 5x squared. 5x times 3 is 15. X. 5x times 3 is 15x. Now, I divided, I multiplied. Next step is to subtract. The 5x's cancel out. 4x minus 15x is negative 11x. Next step, bring down the next number, and here that would be negative 7, the next term. Okay, so I go back up. I was down here. I go back to number 1 again. Divide. X, negative 11x divided by x. The x's cancel, so that gives me negative 11. So I'm going to put that up here. I divided, and I need to multiply. Negative 11 times x is negative 11x. Negative 11 times 3 gives me negative 33 minus. So I subtract. Subtracting is the same as adding the opposite, so I'm going to add, and the opposite of these two would be positive terms. Negative 11x and 11x cancels out. And then I have negative 7 plus 33, which is going to give me 26, and that's actually my remainder. So my answer is the quotient, 5x minus 11, plus the remainder of 26. Now, to check this out, I'm going to say, okay, the dividend equals the divisor times the quotient plus the remainder. Okay, let's make sure this checks out. That's 5x squared minus 11x plus 15x minus 33, just using the FOIL method, plus 26. Simplifying to get 5x squared, negative 11x plus 15x gives me 4x. Negative 33 plus 26 is negative 7. And this does check out. So again, this is really just using the same techniques as you use for long division with numbers. Now, one thing to be aware of is that sometimes there are missing terms. And if that is the case, you need to use a coefficient of 0 and represent those terms when you're dividing. Now, if you think about it, when we have numbers like, say, 107, we have a 0 here as a placeholder. When we're doing long division with polynomials, we need to do the same thing. For example, let's say you were asked to divide 3x cubed plus 6x minus 4, and you're asked to divide that divided by x plus 2. If you look here, there's a missing term. I have an x cubed term, but I have no x squared term. And then I have an x and a constant. So I have a missing x squared term. And really, I can represent that x squared term by giving it a coefficient of 0. And I need to do that before I divide. So if I have x plus 2, that's my divisor. My dividend, what I'm going to write here is 3x cubed plus my missing term, 0x squared, plus 6x minus 4. And then I'm going to go about long division like I usually do. So I take 3x cubed and I divide that by x. And that is going to give me 3x squared, because 3x cubed divided by x is going to give me 3x squared. Okay, so I divided. Next step, multiply. 3x squared times x is 3x cubed. 3x squared times 2 is 6x squared. Next step, subtract. These cancel out. This is 0x squared minus 6x squared. And you can see how if you didn't have that missing coefficient in there, you'd get a completely different answer. The missing term. Okay, so now I've got negative 6x squared. I'm going to bring down this next term, 6x. Okay, now x goes into negative 6x squared. Negative 6x times. So I'm going to put negative 6x up here. I divided. Now multiply. Negative 6x times x gives me negative 6x squared. Negative 6x times 2 is negative 12x. Now I'm subtracting, but remember that is the same as adding the opposite. I'm going to change these signs. These cancel out, and then I end up with 6x plus 12x, which is 18x. Bring down the next term, negative 4. Okay, x goes into 18x 18 times. So up here, I'm going to have an 18. 18 times x is 18x. 18 times 2 is 36. Now I subtract. 18x minus 18x, that cancels. This negative applies to here as well. So I have negative 4 minus 36 to get negative 40. So the remainder equals negative 40. And so my answer is 3x squared minus 6x plus 18 with the remainder of negative 40. Again, the key point here was to make sure that when you notice that there is a missing term, the x squared term is missing, to represent that using the coefficient of 0. Okay, there's another way to divide that is much faster and easier than long division, but it is only applicable to dividing a polynomial by a binomial. So when you have those cases, synthetic division is an excellent method to use. Now, there's another restriction, and that is that the divisor, which in this case is the binomial, must be in the form x minus r, where r is a constant. So the divisor has to be in this form. If it's not in that form, you have to get it into that form. Okay, so let's take a look at an example where the divisor is already in this form, to keep it simple for now. 3x cubed minus 2x squared plus 7x plus 4. If I'm asked to divide that by x minus 2, and it is in this form of x minus a constant, I could use long division, but you'll see that this is a much faster method. So first, draw a symbol like this. Now, you put the r term right here. So in this case, it's 2. And this says minus 2, but you actually use the opposite sign. If this were to say x plus 3, then I would put a negative here. So this is x minus 2. I use the opposite sign, so I'm going to put a 2 right here. Now, what I write in here are the coefficients of the dividend. 3, negative 2, 7, and 4. And just as with long division, if there's a missing term, like let's say my x squared term was missing, I would have represented that here with a coefficient of 0. Same idea as with long division. Okay, so here I have the constant. Here I just have the coefficients from up here. The first step is to bring down that first coefficient and just put it here. Okay. Second step, multiply. 2 times 3. So I'm going to multiply 2 times 3, and my result will be 6. All I'm going to do is add this to negative 2. So negative 2 plus 6, that's going to give me 4. Then I repeat that process. I'm going to multiply negative 2 by 4 to get 8. And I'm going to add. 8 plus 7 is 15. I'm going to repeat that again. Negative 2 times 15 is going to give me 30. And I'm going to add again. 4 plus 30 is 34. Now, what do these numbers represent? Well, they represent the quotient and the remainder. And to write them out, what you're going to do is look at the dividend. And the quotient is going to be a degree 1 less than the degree of the dividend. So the degree of the dividend was 3, so the degree of the quotient is going to be 2. So I'm going to write this out as 3x squared plus 4x plus 15 with the remainder of 34. And you can see how much quicker and easier this is than long division. So again, write the constant from the divisor here. Write the coefficients here, making sure to use 0 if you have a missing term, using 0 as a coefficient. Bring down the first term. Then multiply the divisor constant by this number and get a product. Add that to the next column. Then multiply 2 times this number, 4, to get 8. Add to this column, 15. 2 times 15 is 30. Add to this column to get 34, which is the remainder. Okay, as I mentioned, the divisor must be in the form x minus r. If the coefficient of x is not 1, you need to rewrite it so that the coefficient is 1 in order to use this method. For example, if I was given 3x cubed plus 12x squared minus 15x plus 6 divided by 3x minus 9, I can see that this coefficient is not 1. In order to make it 1, I need to divide each term in both the dividend and the divisor by this coefficient. So I'm going to divide each term by 3, and that's going to give me x cubed plus 4x squared minus 15x plus 2 divided by x minus 3. Now I can go about synthetic division in the usual way. And as you'll see here, I lucked out, and dividing things by 3 still kept everything as integers. However, it's very possible that when you divide by this number, you're going to end up with some fractions. So that is a drawback, and it makes it more complicated, but it's necessary to do this in order to use synthetic division. Okay, first we're going to practice dividing a polynomial by a monomial, and you'll recall that the technique is to divide each term in the polynomial by the monomial. So rewriting this, dividing each term by the monomial. Okay, so 20 divided by 4 gives you 5. The x's cancel out, and then y4 divided by y2, this 4 minus 2 is y squared, 5y squared. 12 divided by 4, and there's a negative sign in front of that, gives me 3. X to the first minus 2, this is going to give me x to the negative 1, and I'm going to have to take care of that in a minute to put it in my final form, but for right now we'll leave it like that. Y to the third divided by y squared. 3 minus 2 just gives me y. Plus, just leave this as 5/4. X to the third divided by x squared is x. And then here I have y, which is really y to the first, divided by y to the second is 1 minus 2, and this is y to the negative 1. Now remember, you want to simplify things, and they're not in simplest form if you have negative powers. So recalling that rule that a to the negative n equals 1 over a to the n, I can simplify by moving this x to the negative 1 to the denominator. And I can do the same thing here. X stays up here, y moves to the denominator. And this is my answer, dividing a polynomial by a monomial, and then simplifying. Okay, this next problem, dividing a polynomial by a binomial, could be done by synthetic division, because it is in this form x minus r. But just to get a little more practice on long division, let's do long division on this one. Okay, x goes into 3x squared, into 3x cubed, into 3x cubed. This becomes 2, so this is 3x squared. So it goes into it 3x squared times. So I divide it. Now I'm going to multiply. 3x squared times x is 3x cubed. 3x squared times negative 3 is negative 9x squared. Now I'm subtracting, and that is the same as adding the opposite. So this becomes negative, this becomes positive. These cancel out. So I have negative 2x squared plus 9x squared is 7x squared. Bring down the next term, and then divide again. So I have 7x squared divided by x equals 7x. 7x times x, 7x minus 3 gives me negative 21x. Subtract, which means I'm adding the opposite. This becomes a negative, this one becomes a positive. This cancels. 4x plus 21x is 25x. Now divide again. 25x divided by x. X's cancel. That's 25. So I'm going to have 25 up here. Multiply. 25 times x is 25x. And bring down this next term. So I have negative 8 there. So 25 times negative 3 is going to give me negative 75. I'm going to subtract, which is adding the opposite. So that's negative 25, positive 75. These cancel. Negative 8 plus 75 is 67, and that's my remainder. So the answer is 3x squared plus 7x plus 25 with a remainder of 67. So that was long division. Now, this next example specifies to divide using synthetic division. And I'm checking, and this is in the form, the divisor's in the form x minus r. So I can go ahead and do it without any further manipulation of the expression. So recall, in synthetic division, set it up as follows. You're going to put the constant here with the opposite sign. This is negative 4. I'm going to make it a 4. Now, before I proceed with putting the coefficients in, it's very important to check for missing coefficients. And I'm looking, and I have y to the 4th. I do not have y to the 3rd. I have y to the 2nd, y, and a constant. So I'm going to rewrite this. Using 0 for my coefficient with the missing term. So I have a missing y cubed term, and I'm going to rewrite it, and the coefficient's 0 to use that as a placeholder. So this is really what I'm going to do. Okay. Now, I'm going to use these coefficients. I have 5, 0, negative 3, 2, and then my constant, negative 8. Okay, the first step is just to bring down that first term, 5. Second step, multiply. 4 times 5 is 20. After multiplying, add. 0 and 20 is 20. Multiply again. 4 times 20 is 80. Negative 3 and 80 is 77. 4 times 77, if you calculated that out, you would find that it's 308. 308 plus 2 is 310. 4 times 310, if you work that out, you'll find that it's 1240. 1240 and negative 8 is going to give you 1232. So again, write the coefficients here, being careful that to realize you have a missing term, so you need to represent the coefficient for that missing term as 0. Bring down the first term, and then multiply and add that product to the next column. Find the sum. Multiply, add the product to the next column. Find the sum, and continue on. Now, for my quotient, this is the quotient. This is going to be the remainder. The quotient is going to have a degree 1 less than the degree of the dividend. So the degree of the dividend is 4. So the degree of the quotient is going to be 3. So I'm going to write this out as 5y cubed plus 20y squared plus 77y plus 310. The remainder is 1232, which is a big remainder, but this is correct. Okay, in this example, we also are asked to do synthetic division. And I check, and I've got a couple things going on here. I've got a missing coefficient, and this is not in the correct form of x minus r. So dealing with the missing coefficient, missing term. I have a missing term, which I'm going to represent with the coefficient of 0. So first, addressing the missing term. I'm missing a z squared term. So I have 6z to the 4th minus 8z to the 3rd. Since I have no z squared term, I'm going to use the coefficient of 0 for that, 0z squared, minus 4z plus 8. Okay, that's taken care of. Now, the other problem I have is that this is not in the correct form. In order to have this z have a coefficient of 1, I need to divide all the terms in the divisor and the dividend by 2. So I'm going to do that. So divide by 2. Divide each term by 2. Divide each term by 2 to get the form. I'm going to say z instead of x because we're working with z minus r. Okay, so 6z to the 4th, dividing that by 2 is going to give me 3z to the 4th. 8z cubed divided by 2 is negative, so it's negative 4z cubed. 0z squared divided by 2, 0z squared. Negative 4z divided by 2 is negative 2z. 8 divided by 2 is 4. So far, pretty good. 2z divided by 2 gives me z, which is what I wanted. Now here, when I divide negative 1 by 2, I am going to get a fraction. And it makes it more difficult to work with, but you can still do the synthetic division. Now I'm ready to set this up. Here, I'm going to take negative 1/2. I'm going to take the opposite sign and write it here. So that is 1/2. Then I'm going to put the coefficients here, my new coefficients after dividing. 3, negative 4, 0, negative 2, and 4. Okay, bring down the 3 and multiply 3 by 1/2. So 3 times 1/2 is just 3/2. Okay, 1/2 times 3 is 3/2. Now, you might need to work out the arithmetic on the side, and that's fine. So I have negative 4 and 3/2. So negative 4 is equal to negative 8/2. I want to get the denominator, a common denominator. Adding that to 3/2 is going to give me negative 5/2. So this is negative 5/2. Now, multiplying 1/2 by negative 5/2 is going to give me negative 5/4. So this times this is going to give me negative 5/4. 0 and negative 5/4 is just negative 5/4. Now I have to multiply 1/2 times negative 5/4. And this is going to give me negative 5/8. So I have negative 5/8 here. I want to get a common denominator, and so I'm going to do negative 2 times 8, which is going to give me negative 16/8. So this is negative 16/8 plus negative 5/8, and it's just 16 and 5 is negative, so I have negative 16 and negative 5 is negative 21/8. So combining these to get negative 21/8. Okay, now 1/2 times negative 21/8 equals negative 21/16. So this times this is negative 21/16. I have to add that to 4. So I want to figure out I want to get a common denominator. So 4 times 16 is going to give me 64. So 4 equals 64/16. So I want to take 64/16 minus 21/16. And that is going to be 64 minus 21 is 43/16. Okay, this was kind of messy to do, but synthetic division does work, and will end up giving you the correct answer. So what you need to look at here is that this is a degree of 4, so this is actually going to be a degree of 3. So rewriting this up here, my quotient is going to be 3z cubed minus 5/2 z squared minus 5/4 z minus 21/8. And I have a remainder of 43/16. So two things to notice. We had a missing term here. The z squared term was missing, so I had to use coefficient of 0. And the second is that this was not in this form, so I had to divide every term in the numerator and the denominator, the divisor and the dividend, by 2, and then proceed as usual with synthetic division. So that concludes this lesson on dividing polynomials for educator.com, and I will see you again soon.